Okay, we're now answering the first question of this exercise, in which we're given the first few terms of a sequence, which are -3, 0, 5, 12, 21, and 32, and we're asked to find the formula for the nth term of the sequence. Now, as always, the first thing to do here is to look at the difference from one term to the next. So from -3 to 0, we're adding 3. From 0 to 5, we're adding 5. From 5 to 12, we're adding 7. From 12 to 21, we're adding 9. And from 21 to 32, we're adding 11. And since the difference here isn't always the same, we look at the second differences. So from 3 to 5, we're adding 2. From 5 to 7, we're adding 2 again. From 7 to 9, we're adding 2. And from 9 to 11, we're also adding 2. Since we're always adding the same amount here in the second difference, it means we're dealing with a quadratic sequence. So it must have a formula looking like un equals to an squared plus bn plus c. And now to find the coefficients a, b, and c, we use the following formula. 2a equals to the second difference. So in this case, that would be 2. We also have 3a plus b must equal to the difference between the first and the second term of the sequence. So that would be this 3 here. And finally, a plus b plus c must equal to the first term of the sequence. So here it's -3. Those are our three formula. And we're going to solve this working through them from top to bottom. So we start with 2a equals to 2. That tells us that a equals to 1. Looking at the second one, we have 3a plus b equals to 3. And since we've just seen that a equals to 1, that becomes 3 times 1 plus b equals to 3. So 3 plus b equals to 3. And quickly we see that b equals to 0. And the last one, we have a plus b plus c equals to -3. And since a equals to 1 and b equals to 0, that becomes 1 plus 0 plus c equals to -3. That's 1 plus c equals to -3. And therefore c equals to -3 minus 1, which is -4. We now have all three coefficients, and we can state the formula. That would be un equals to 1n squared, we just write n squared, plus 0n, we don't bother writing that, plus -4, which leads to -4. And that's the formula for the nth term of this sequence.